These are the notes for Unit 9, Day 11. We're going to talk about the quadratic formula. This will be review. The only new stuff is what to do if we have a negative underneath the root, because we now know what we can do with that. So remember, when we want to use the quadratic formula, this will solve any quadratic. So when you're stuck and I asked you to solve it using any method, you can always use the quadratic formula. It might not be the fastest, but it will always get you your solution or solutions. So the quadratic formula here, you can see that big long form with the B's and the A's and the C's. You can sing Pop Goes the Weasel, and that will help you remember it. So you could sing x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's an easy way to remember it. What we're going to do is we're going to talk about the discriminant a little bit. So the part underneath the radical we call the discriminant. That will tell us how many solutions we have and the type. So it tells us the number and type of solutions. And basically, we're going to get two solutions unless the discriminant is equal to 0. So we're just going to essentially look at this. If it's positive, how many solutions are we going to have? We're going to have two solutions. And the types of solutions, they're going to be real. Because if you take a positive number and take the square root of that positive number in this positive negative context, right? Because we have this plus minus, you get one positive, one negative real root. 0 only has one square root, so you're only going to get one root, but it will be real. And then if you have a negative underneath there, before we used to say no solution, but now we're going to have a positive negative I, right? Because we have that I we could take out. So we're going to say those solutions are complex. And sometimes they'll say imaginary, so it's good to know that those two kind of mean the same thing. We could also say non-real there. We'll kind of use those interchangeably. Any of those is fine. So here's our little summary. If b squared minus 4ac, that is the discriminant, is positive, then we're going to get two real. And if b squared minus 4ac is 0, you get one real. And if you have b squared minus 4ac is less than 0, meaning it's negative, that is two complex solutions. So that is our little summation there. But you could see that language we're using, the b squared minus 4ac, they're saying discriminant without actually saying discriminant. Now, here's what we're going to do. For this little section here, I'm going to do the first one because these go pretty quickly. Remember, your a is whatever's in front of x squared. This is my b value, this is my c value, and I'm going to do b squared minus 4ac. Now I'm going to show you a little hint here, or a little thing that can help you calculate this. What I'm going to do is I'm going to use parentheses, and if I use these parentheses, it's going to enable me here, I forgot my squared, to just drop the a, b, and c in. So there's my a and there's my c. As long as I have those signs, I can type those in. Now if I want to, negative 5 squared is 25, and then negative 4 times 1 times negative 6 would give me a positive 24, which should give me 49. All right, now let's say I'm not sure about that, right? That negative on the second part really kind of throws me off. Well, if you use your calculator, you put your parentheses in the right spots, and you type this in. Notice I'm doing this exactly as you see it there. And I hit enter, and it will verify that it is in fact 49. So what does that mean? It means I have two solutions because it's a positive, and those are real because they're positive. So again, if you need to go back and use your chart for 2, 3, and 4, you can certainly do that. Okay. Now, what we're going to do is we're going to solve number 5. We're going to set it up in the quadratic formula. So I took the liberty of, this is exactly the same problem. I took the b squared minus 4ac and populated that in there. It's negative b, so that's saying negative 5 in this case, and then 2 times 1. So we're just going to simplify as we go. And I think this is probably the easiest way to do it, to actually put everything with the parentheses in, plug everything in, and then if you need your calculator for that square root part, I would suggest you use it, but as we saw, it was 49. And then 2 times 1 is just 2. Now this problem what we're going to see here is this is going to be 5 plus or minus. What's the square root of 49? Well, we know that that's 7. Now, this is a little bit strange looking, but we can actually split this up. So I'm going to get two answers here. 5 plus 7 equals 2, and 5 minus 7 equals 2. And if you do this one step at a time on the calculator, you're going to be just fine. So 5 plus 7 is 12, divided by 2 is 6. 5 minus 7 is negative 2, divided by 2 is negative 1. So there's my two solutions right there. Boom, we're good. All right, so we'll try some of those other ones over there in class, but I want to look at example number 9. I want to look at what happens when we don't have a nice perfect square in there. Well, that's something else we have to deal with. So I look at my A, my B, and my C values here. So now negative B, or the opposite of B, and then B squared minus 4AC, my C is 1, and then in the bottom 2 times A, right? So we're just going to clean this up a little bit. I wrote that kind of large. I could probably shrink this down a little bit. I don't know, I wrote that so big. So I'm just going to clean this up just a little bit. So I'm going to get positive 8 plus or minus, and then here, I'm not going to like rewrite this a bunch. You know, you can kind of do your work off to the side. This is going to be 64 minus 12, which will be 52. Now, I'm going to get a root underneath. That 52 is underneath a root. So I'm going to simplify this. This is root 4 times root 13. So this will simplify to 2 root 13. So it's kind of nice to like do that off to the side. That'll save me the grief of like writing this over and over again. So this is 2 root 13 all over 6, 2 times 3. Now, I call this the heart method. You draw a nice heart around this. And if those three numbers can be divided by the same number, you reduce them. If they cannot, then you do not reduce them. Now, I kind of got that 13, but that 13 is underneath the root. So we're going to ignore that 13. And 8 divided by 2 is 4. 2 divided by 2 is 1. Root 13 stays root 13. And then 6 divided by 2 is 3. My two solutions are 4 plus or minus the square root of 13 all over 3. And that is how we use the quadratic formula. So we'll do the rest of those problems in class. Thanks for watching the video.